This is R.D. Sharma solution, class 12, chapter 9. Continuity exercise is 9.2. Discuss the continuity of the following functions. Now here if you see, we have sin x plus cos x, sin x minus cos x, and sin x cos x. In all of these parts, sin x and cos x, there are two different functions. And for example, if you take one function is f, one function is g, then this is nothing but the operation between the functions. That is, if you have function g, the other function as h, g in this case is sin x, h in this case is cos x. So what we are doing is, we are adding two functions, that is sin x plus cos x, which is g plus h. Then we have g minus h, so sin x minus cos x, and then sin x multiplied by cos x, that is you are multiplying. So sin x and cos x by themselves, they are continuous, but we are g plus h, g minus and g into h doing these operations on these two. So how does this cos x and sin x are continuous? Because if sin x and cos x are continuous, then the operation should be continuous. Okay, so the function of two functions, the operations are continuous, but are these functions by themselves continuous? That we have to see. So first we have to tell or show that sin x is continuous. So this gx is our sin x, we assume it to be sin x, and since sin x is defined, or you can say it's defined for every real number. So let us take any value c or k, whichever you want. So at this point c, let's check whether it is continuous or not. So what we do here is, we are taking c as constant, and you just say that x is approaching c, or the value of x at c is what. So in this sin x and cos x, what you do is you replace x by c plus h. So when you put the value of c in this function, it should be sin c. That is, when x is approaching c, you should get sin c. I am just saying that x is not equal to c, but x is almost equal to c. So gc should be equal to sin c. If this is possible, or this can be shown, then we can say that this function is continuous, because we are going to check for c plus h or c minus h, left hand side or right hand side. So it's up to you. You want to put c plus h, it's up to you. C minus h, it's up to you. I am replacing x by c plus h. Okay, so x minus c is h. When x is tending to c, what does it mean? When x and c are same, x minus x or c minus c is 0. So h tends to 0. So when x is tending to c, or x is similar to c, and h tends to 0, then this gx, when we apply this limit, that this gx function, when the x is actually approaching c, and as I said, x we are replacing by c plus h. C can be any constant, but x is that value which is to be defined for every point in that domain, which is the real number. So we have limit x tends to c, sin, and x, but as I said, x is c plus h or c minus h, whatever you want to put. I am replacing x by c plus h. So this sin c plus h, and sin c plus h is, because we have to open it using sin a plus b. So sin a cos b plus cos a sin b. This is sin a plus b. Now limit is already there, and this limit is x tends to c, but when x tends to c, so h tends to 0. So both sides we will apply h tends to 0. So when x tends to c, h tends to 0. Okay. Now this is sin c cos h. So sin c is constant, take it outside, limit h tends to 0, cos h plus cos c I am taking constant, then limit h tends to 0, it is sin h. Now cos 0 is 1, so sin c into 1 is sin c. Sin 0 is 0, so this whole term will be 0. So you get sin c. So limit when we have x tends to c, gx is sin c, and in beginning I told you, if we can get gc as sin c, that is, it is continuous. Clear? So now this is done, sin x. Same thing we have to do for cos x. And this, you don't have to prove sin x plus cos x is continuous or not. Sin x individually, cos x individually, if they are shown to be continuous, then the operation, that is plus minus multiplication, they will always be continuous, which we have seen in the theory or discussion also. So let me excuse me, let me change this cos x we are doing. So this same thing, the what we applied in sin x, same thing we'll do. That is, there is a number line and this is c or real number, any c. So x is approaching c. So we can always put h, this c plus h or c minus h. That is, when x is tending to c or x just becomes equal to c, the h will be tending to 0 because x equals c plus h or c minus h, whichever way you take. So what we are trying to do here is limit x tends to c, the hx function which we have taken as cos x, when we replace x by c, so hc will be what? It will be cos c. So let us see whether it comes cos c or not. So replace x by c plus h or c minus h, whichever you want. I am replacing x by c plus h. So this will be limit x tends to c, cos x, and in place of x what we are going to put? C plus h. So limit x tends to c, and when x is tending to c, that means h is tending to 0, because x minus c, x is equal to c or c is equal to x, h is going to be 0. So limit h tends to 0, cos x, in place of x I am replacing it by c plus h. So this is cos a cos b minus sin a sin b. Cos a plus b formula is cos a cos b minus sin a sin b. Now I'll apply the limits individually to both the terms. So both we are applying. Okay. So this is cos c I am taking outside. Limit h tends to 0. It is cos h. And then we have minus. Again take the constant sin c outside. Limit h tends to 0. And this is going to be sin c, limit h tends to 0, sin h. Okay. Now cos h tends to 0, so cos 0 is what? It's 1. Sin 0 is 0, so whole term will be 0. Cos c it is. So this cos c, if we can get it, I told you earlier, limit x tends to c hx, which is our cos x. If it equals to cos c, if we apply hc, then we say it is continuous. So sin is continuous, cos is continuous, so sin x plus cos x will be continuous. Sin x minus cos x will be continuous. Likewise, sin x into cos x will be continuous. Show that the function fx equals cos x square is a continuous function. So this cos theta, now theta is x square. So cos x or cos theta or cos whichever is continuous, we have just seen in our question. And this theta which we are representing by x square is a polynomial function. This is already continuous. What I am trying to suggest here is cos x square is a combination of two functions. Cos theta or cos x or cos whichever value is fx. Theta is x square, which is gx. So cos x square is nothing but function f of gx. That is, when you put this gx inside f in place of x for fx, then you get this cos x square. So f of gx is nothing but f operation gx. And we know when we have f as a separate function, g as a separate function, then the operation of f of g will be continuous if f and g are continuous by themselves individually. Okay. So cos x we have just seen in the question. There are multiple questions coming in the later part where I'll say that cos already we have done. Just now we have done in the previous question. So this is the same thing you have to do. I'll just show you again just to revisit. Okay, I assume that this cos x is done. Now we have to come for this x square. But we know already that this x square is a polynomial function. It will be continuous. But it's not like that. You have to prove it. So this sin x cos x is we have already seen. x square is continuous, because when x square is continuous, when cos x is continuous, then cos x square will be continuous. So you have to take them separately. So take any number line, because it is defined hx equals x square is defined for every real number. So let us take k or any c. We have already taken c, so let us take k. So hx is x square, so hk will be k square. So when x is tending to k, that is x is approaching k, limit x tends to k, so this x square, what do you get? This is going to be k plus h. You can just replace it by k plus h. Then also same thing will come. X is, if you replace by k plus h, it will be k square plus h square plus 2 into k into h. Now apply limit h tends to 0. X tends to c or x, so h tends to 0. Right? X is c plus h, which we just saw. It can be c, it can be k. I am using them interchangeably. So h square and 2kh will be 0, so it will be k square only. So let us apply limit h tends to 0 when x is tending to k. So c plus h or c plus h in place of x I am replacing. So it is going to be k square only. So basically the idea is, take any point, say that x is approaching k, and the function should come as the value of the function at that particular value. So fk will be k square. So this is continuous. Cos x we already done. So cos x square will also be a continuous function, because basically it is an operation. Now this question, fx equals mod of cos x. This is a continuous function. So we have fx, which is, there is one function which is modulus function. It can have anything inside. Just imagine you have just a modulus function. We have another function which is, say, called as hx, and that is cos x. And what is gx? Mod of hx. Mod of hx. So mod of hx is what? Mod of cos x. So ultimately what you have placed inside x? You have placed hx inside x. So basically it is g of hx which is giving you this mod of cos x. So g of hx is what? Gof or gotch x. It is operation only. So one function is modulus of x, one function is cos x. When we apply them, there is a simple operation which is g operation of h. So this is just an operation of two functions. So if we are able to show that both the functions, which is one is modulus function, one is cos function, if they both are continuous, then the modulus of cos x will also be a continuous function. So this cos x we have already done. So I'm not going to repeat it again. It will just be a repetition. But mod x we will just see here. So cos x already seen. You can have a visit here. Cos x we already shown, because we have to show in this question also that cos x by itself is continuous. Then only the operation will be, the operation with the modulus will be of continuous function. So this operation you have to show, mod x you have to show, and cos x by itself you have to show. I am not showing the cos x, I am just showing you the modulus of x. So modulus of x when x is greater than 0. Modulus of x will be negative x when x is less than 0. That is, on the negative number line it will be negative x, it will be positive number line, it will be positive x. So when you take a number line, you can be taking any value c. This c or k, it can be less than 0, it can be greater than 0, it can be equal to 0. So the constant you have taken can be less than 0, can be greater than 0, can be equal to 0. All the cases you have to take, because you are showing mod x is continuous, right? So what c is there when this x is approaching this c, because eventually you are talking about x. You take any constant c or k or whichever, ultimately you have to talk about x, because here x is approaching c. So gx is equal to mod x, which is what we have presumed. So when you have limit x tends to c, that is x is approaching c, or x will be equal to c, and when you apply this on gx, it should be gc. Okay. So gc is what? When you put this GC, or you can say x is less than 0, it is going to be negative x. So GC is nothing but what? It is modulus of x, here modulus of c. And since c is less than 0, it is going to be minus c. So now you replace this GH, that is, you have to put this GC was minus c, and GX is what? Modulus x. Modulus x, when you are saying it is less than 0, because x is approaching c and c is less than 0, so x is less than 0, it is going to be negative x. But we are talking about c, not x, so it is going to be minus c. Okay, so Gx, when you apply limit x tends to c, it is going to be minus c. Actually, minus c is equal to minus x. So minus c in both the cases when it is less than 0. So when both are equal, that is for c less than 0, it is justified. When you have greater than 0, when c is greater than 0, what you do? Gx is what? It is modulus of x. When you apply this limit x tends to c, that x is approaching c. So you are talking about modulus of x, which is modulus of c. Modulus of x or modulus of c, or when c is greater than 0, it is going to be x or c. And what is GC? It is modulus of c. C is greater than 0, so it is going to be c only. So in both the cases, when Gx, x approaching c, it is c, and GC by itself, the value of the function at c is going to be c. Two are justified now. Now third one, c is equal to 0. Now c equals to 0, we have to go left and right. That is 0 minus h and 0 plus h, that is left hand limit and right hand limit, both you have to take. 0 minus h is 0 plus h. So 0 minus h is minus h, 0 plus h is mod h. Okay. So when you take the limit h tends to 0, limit h tends to 0 here, in both the cases you will get 0 only, because minus 0 is actually not defined, but mod of anything negative will be positive only, because mod of minus x is nothing but minus of minus x. I showed you already, mod of x less than 0 is minus of minus x. So both the cases you get 0. So left hand limit equal to right hand limit. Okay. So here all the three cases of mod x we have taken for any c, and we have showed that this modulus of x is continuous. Cos x you have to show by yourself. Okay. I'm just not doing it again. Okay, this question we'll take in the next discussion. Till then, thank you so much. Take care of yourself.